All right, what's good, Joe? I'm gonna work on a homework. Like, give me one moment. Two-factor authentication. Okay. Because I have a. Oops, wrong one. Where was I at? Here we go. Um, so I have a lab due today, and I'm behind on it for sure. But it's just a bottle lab. I have like how much time am I gonna spend on this? I guess spend the full hour actually. Um, oh, it's broken. Oh, there we go. It only works on. I'll have to fix that or submit a PR for it. Either way, this thing boots up. Please say no. The server can't be down because let me connect to it. It's taking a lot longer than it usually does. There we go. Okay, let's do auto, and then I need this. Bam, bam. Actually, did I put that PDF in here? Because if I did, then it's just a lot easier to open that PDF. So 426. Here it is. All right. So open the project. 426. Here we are. So I think what I left off on is I created a full adder for the first component of the ALU. So that will handle both addition and subtraction. Yeah. So this is the n-bit adder here. This ALU is going to be 32 bits, so I made it 32 bits. Now I need to make a test bench for it. So what we're going to do is we're going to add a source. This is a simulation source. And this is going to be n-bit bit adder. Cool. Finish. Yes. What is it? Oh, it is alt tab. Okay. See, I remember how to use Windows. I'm a genius. What was I looking for though? This needs, yeah, right. So I should have another test bench in here where I did the 1-bit. So we can copy this and then go to the n-bit adder. Oh, I named this wrong. Remove. Okay. Next, create n-bit adder test bench. Okay. Yes. Okay. Okay, now we're good. So we can highlight all this, paste, and then what needs to happen is known vowels, standard logic. Okay, so this is going to be, so A is now going to be a standard logic vector from 31 down to 0. And then we can append these on the end. Yeah, this is going to be that. This is going to be that. C in the standard logic. Yeah, standard logic. Cool. So A vowels, n-bit adder. You know what I could do? I think project. I did 360. So for the ALU that I did, no, I wanted the ALU test bench. Adder test bench. Yeah. $15. Oh, right. I'm missing some stuff. Actually, you know what I should do? I should just copy this instead, because that would be better. So let's paste that. Right, so this is what, 16-bit? I have 32-bit now, so this will need to be 31. And then we have, all right, so yeah, so we have C out and C in. So we don't have a mode because this isn't an ALU yet. We don't have 0. We do have C out. And then we need a C in. So type C in array is array 0 to nonvowels -1 of standard logic. That's it, because cin is just a single value, right? So for these, what I'm gonna do is I'm just gonna extend these. So we have another 16 bits. We can have the same number if we just extend the first value. And then this will be this. So we have 1 here. It'll still be 1 if we just put a bunch of 1s in front. And then I think that's it. Modes does not exist anymore. Oops. And then 0 also does not exist. Output enable doesn't exist. I kept the semicolon, that's weird. So C out is, we're not gonna get C out, this is 0. Actually, we can take the answer. Let's do the answer first. Oops. Wrong thing. This. And then let me tab this over. Never mind. All right. So I need my, do I have 1s still? No. So I need this. Oops. I need this. Bam, 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 bam. We're missing 1. Oh. This started over more. That's what it is. Yeah, that's the same length. Okay. I got scared for a second. Okay. So we have all of those. Now we need the 1s, which is this. All right. So, oops. I was hitting Shift S. All right. So for the C out, we would carry. Okay, so I think it would follow the same. So these are 0 still. This signal does not exist. This does not exist. Oh, I'm missing C in as well. Right. So zeros, we're gonna have. Oh right, we do need to test Cn now. Okay, so firstly, let's test this range. So Cn will need to be 0 for all of these, as to not affect it. Oh, right. Sorry, I was using Cn to add 1. Therefore, it would be used for subtraction. I would just not it, but that's later. So full zeros, 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 and then C out is also 0. A negative and a positive. So it's negative, positive. Yep, okay, so that would not be C out either. And then negative. This would also not be a carry out. Positive and a negative, that sums to 0. Wait, I'm on the wrong one. Fourth, that's a fourth one. Pause. 1, 2, 3. Yeah. So a negative and a positive. So it's negative 1 and 1, and that sums to 0. And then we have this one, which is 1, 2, 3, 4. Did I put an overflow on this? Wait, I'm looking at the wrong thing. No, this is the adder. Embed adder. I did put overflow. Okay. So I also need the overflow value too. Constant overflow is. Oh wait, I need to do it sequentially because this isn't defined yet. Overflow array is array from 0 to num. Wait, no. Yes. Num vals minus 1 of standard logic vector from. No, it's just that. Because this is a singular value. No, wait. Not standard logic vector. This is just a standard logic value. Right? So, where's I at? Oh, yeah. So this needs to be, I need an overflow array. Because in the 365 lab, we did overflow, meaning, no, we did C out, but it wasn't the right kind. So overflow vals is overflow array, which is the following. So I think we would need another test. This is what did we do for this? So this is 1, 2, 3, 4, 5. This is the fifth one. 1, 2, 5. This one. So you have a negative and a negative, and you get a positive. So that is an overflow. And I think it carries. Because we have, okay, hold on. So we have why isn't it letting me? Oh, it didn't copy it. Okay, and then bro, copy it, please. Okay. So if you add these together, oops. you get the following. So you start over here first of all. So this is a 1. Okay, I'm gonna just do this on paper because it's gonna be faster. Right, so it's 4. Okay, so the first. Oh, that's why it was overflow. You don't want the same number in this instance. I might have to redo these. Because the reason that it was overflow for 16 is because you got the max number. And then you were adding 2 really large negative numbers together, and you were getting a positive. So let's go over this. So full zeros, 1 is good. And then a negative and positive, that's also good. Positive and negative, a negative and negative, that's also fine. Positive and negative, that sums to 0. That will also be the same if we extend it. Now this one is, yeah, I think this might be the only one that we need to change. So for the second to last one, this would have to get rid of this, and then this would have to be, actually, hold on, let me make zeros on here. And then this would be like that. And then for this one, it's the same exact thing. 0. All right. So given that, we'll have a really large negative number and really large negative number. The max negative number plus the max negative number minus 1. And then you'll get, yeah, because these will carry over, right? So you get carry for sure. And this is 1, 2, 3, 4, 5. Yep. So I have that, but it's also going to overflow. So for the, yeah, 0, 0, 0, and then 1, right? So let's double check this. So positive, 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 no overflow. Negative, positive, that's not going to be overflow. Negative, negative, and a negative. That's fine. 4 is a negative, and you get a positive. Wait, is that 4? No, that's 5. This is the one we just did. And then a positive, and a positive, and a positive. Okay. So the problem is I want to do 1. The adder instance sheet. Okay. Okay, wait. I want to test these individually though, but I kind of don't want to. I want to be lazy. Carry out without overflow. Example. that the signed result is too big. Carry indicates that the unsigned is. So for instance, on an 8-bit processor, you have OE, which is one, I think it's 1110, right? That's 8, 12, 14. Yeah. Plus 4. Oh, wait, hold up. 0, 0, 0, 0. X4. 1, 0, 0. So the carry flag, but not the overflow. So you get 0, 1, 1. Oh, right, because it's a negative plus a positive. So if I wanted a carry, but not an overflow, you have to overflow. You have to overflow using. Okay, hold on. So let me change this first of all. And carry. We could just put it at the bottom. So overflow only. Carry only. I don't. How can you have an overflow without a carry? Because you have to add all the stuff over. Right? Can you have an overflow? Take the minimum positive value and add a 1. This will result in the sign bit changing, but there's no carry. Take the maximum possible positive value. Awful. Be 0, 1, whatever. Oh, I see. Okay, I'm stupid. Yeah. Okay. I got it now. I don't need this. Can I not put? There we go. Okay, so first of all, we're adding 2, so we'll need 8 slots now. And I'll need to actually do this right. So for overflow only, we'll need, we could just do their example. So it's the max positive and then, let me do one at a time. And then the, just 1. right? Oop. Bro, what? What am I hitting? There we go. So now, what's the problem? Syntax error near. Oh, I forgot a comma. So this will result in just the maximum negative number. Right? But that is an overflow. So 1, 2, 3, 4, 5, 6. 1, 2, 5, 6, 7. Okay. So I am good. And then the C out will be 0. Because it didn't carry. Oh, shoot. I didn't do overflow. Overflow array is. Wait. Oh, I did do overflow. I just don't know why I kept that one. Okay. So C out. Wait. Why is that one so much longer? 1, 2, 3, 4, 5, 6, 7. Yeah, I'm good. 1, 2, 3, 6, 7. All right, so now we need what? Carry only. So carry with no overflow. Could have sworn I had an example already. So if we carry with no overflow, if we just add, so we need to surpass that. So it would be OX. Oh, so if you do this, 0, 1, 1, 1, 1. Wait, hold up. Oh, we could do it negative. Yeah. So what we can do is for this one, we can say the max negative number plus, or no. It doesn't even have to be the max. We just do this. Right? And then we can add the exact same number. So I don't even need to type this out again. And this will result in, so it would be 1110. This thing's starting to lag. Okay, so now overflow will be 0 because the result is still negative. And then C out will be 1. And then C in is also 0. So now we can finish up this. So we have asig, bsig, mode sig, which does not exist. So we need overflow sig, which is standard logic. And then we have C out sig already, which is good. And then we need C in sig, which is standard logic. Cool. So now we map, we map A to asig, B. These two don't exist. Oh, this doesn't exist either. And then C out goes there. We need overflow. I think I did name it overflow. Yep. So overflow is, is overflow sig, and then C in is going to be mapped to, am I doing the wrong layer? C in sig. Right. Oh, right. This is not named that anymore. This is n bit adder. Port A has no actual or default value. It's right here. What? A, B. Yeah. I mapped it already. I'm confused. Asig. Oh, wait. This, first of all, this is wrong. Oops. CN. Oops. Was that what the issue was? Yeah, it was. Okay, so now we need to stimulate the process, so we need to throw the values onto A, B, C in. So C in sig gets the value of C in vowels at the ith index. And then overflow C in. Yeah, those are the only inputs, so we're good. Now we say assert csig cvals, which is good. We check cvals, 0 does not exist. So let's assert that overflow sig equals overflow vowels at the ith index. And then we report that overflow value is incorrect. Severity error. Or I guess it doesn't matter. No, it's, I don't know. Error. So we have C as output, overflow, and then C out is also an output, which is right here. So we're good. So let's try to set that as a top level and see if we can run it. 1 bit. Where is this? Device owner test. Oh. N-bit adder testbench. Alright, that should be good. There we are. So let's set this as top. And then on simulation. And then I need these. Oh, wait, I actually don't need this. I don't need this or this. Let's just say like 300 nanoseconds. Okay. So I have few incorrect. So at 45 nanoseconds, this is wrong. So let's put this in. It says C values. Yeah, C values are correct. Sign decimal. Is that not right? $35,584. That's right. No? See out. What did I write for that? This is C-sig. This is 1, 2, 3. The third one. So I do, it's this one. So the first four should be 0. 1, 2, 1, 2. And then 0101, 0101, 100. So that should carry all the way over. But, okay, so 1. Yeah, so the first 3 get 1s. First 3 get 1s. Oh, that, I think this should be a 0, no? I'm on the right one, right? 3. Yeah, so these go straight down, and then this carries. What is the value of this? Oh, come on, bro. Copy, please. Okay, this actually isn't working. Why is it not copy for the first time? Control C, Control C, Control C. It's not copying, bro. I don't want to type this out. Okay, whatever. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 0, 1. Oops. Okay, yeah. So I think that's on me. I think I wrote it wrong. Well, obviously it's on me. I don't think this the simulation would be the thing that's messing up. All right. Save. All right, so the 45 nanosecond one should be gone. And it is. Okay, cool. So I have 2 more errors to figure out. And then I'll be good. Cool. So let me exit this. And then um 426, I think. Wait, let me make sure I'm on the right slot. Yep. Oops. Shoot, I think. There we are. All right, cool. Now we are all done. Let me disconnect from this. And then